Hi everyone, my name is Antran. Today I'm going to make an experiment for the coefficient of restitution between my basketball here and the surface of the ground to see the bounciness of the ball. More specifically, I want to find out whether the ball would rebound or not. So in order to do that, we need to know two equations. The first one is the equation for coefficient of restitution, and the second one is the equation for principle of conservation of energy and impulse. And so these two equations I will show you right here. Please take a look at it. The first one is the coefficient of restitution equal to the rate speed after collision over the rate speed before the collision. And the second equation is the equation for principle of conservation of energy and impulse, stating that the sum of the energy before collision equal to the sum of the energy after the collision. So what does T stand for? It stands for kinetic energy, is the energy when the object moves, and U stands for the potential energy when the object's not moving, when it stops and stands still. So that's all I need to share with you. Okay, and also you see right here is the equation for kinetic energy, and this one is the equation for potential energy. M stands for mass, G stands for gravity, the value is 9.81, and H stands for height. And the same thing, M stands for mass and V stands for velocity, and we have to square it as well. And since the mass right here and right there, we can factor them out into we can factor them out, and because they're the same, we can cancel them, and eventually we get the equation right here. When you look at this equation, you can see that we know only the gravity is 9.81, the same here and there, so we don't need to find out the gravity because it is the rule of physics. And also we don't know the velocity, the initial velocity before the collision or before something happens, and we don't know the height, the original position before something happens. We don't know the velocity after the collision or after something happens. And the same thing with the H. Here is the height, the final height or the final position. So there we got everything. Now I'm going to show you how it works during my experiment. And now I'm going to set the first for trial 1. I'm going to set the ruler at 49 inches. There, at 49 inch. I don't know if you can see that, it's kind of long. Okay, there, that's 48 and 49 is in there. Okay, so now I have my ruler and it's already set at 49. Now I'm going to pick up the basketball here, there, and I'm gonna move my ruler right there. I'm going to make it touch the ground, and then my hand and my ball with the hand and the ruler, I'm going to put them together, and then I'm going to count 1, 2, 3, and I'm going to drop it. Make sure the end of the ruler touches the ground. So ready? Yes. So 1, 2, 3. Okay, I can see it. I could see that the ball, it touched the 15, could touch the 16 there. So please keep in mind this number, okay? So it's 49 original position and the final position is 16. Okay, let's touch the 16 there. Okay, now I'm going to do second trial. Remember 49 and 16. And now I'm going to do the second trial, but this is my ball, my basketball, and I'm going to set the ruler into let's say 59. I want to see if the coefficient of restitution is going to change if I increase the original position. Okay, so now I'm going to set it at 59. Oh, sorry, it's the other way around. So there is 59, 58, 59. Can you see that there? Okay, so I'm going to set it at 59. Okay, at 59, and now is a little bit longer. You see my hand? You won't be able to see my hand because it's way longer, and I'm sorry for the inconvenience. But there, you see my hand's kind of moving up, so kind of like that. And this, the other hand, I'm going to pick up the basketball. I'm going to move them close together and make sure the end of the ruler touches the surface of the ground, and make sure it's not moving. Now I'm going to drop the ball, and ready? 1, 2, 3. Okay, I can see it when the first bounce, I saw it hit at 50, exact 50. I mean, not 50, 20 right there. It's 20. Just watch carefully, is 20 inches. So it hit at 20 inch. Okay, so that's the final position. And now we know two data, the 49 with the 16, and we know 59 with 20. Remember 49, 16, and 59 with 20. Now I'm going to try the third trial. And again, I'm going to pick up the ball, but never mind, I'm going to set the ruler first. Now, the third trial, I want to see if the coefficient of restitution changes if I change the value of the initial position by decreasing it to probably 36 inch. So there, I'm going to set it at 36 inches, which is 3 feet, 36 inch. Okay, so that is 3 feet, which is equivalent with 36 inches. Okay, there. Now it's kind of short, and hopefully you can see my hand there more easily. Okay, now I'm going to pick up the ball, the basketball that I have right there. And now I just need to kneel down just to be accurate. There. Make sure, again, the end of the ruler right here touches the ground. And let's watch and see how it goes. Ready? 1, 2, 3. Okay. I can see the ball, it hits at 12 inch, which is 1 feet right there, exact. I just observed it very carefully. Hello, so now is time to find out the unknown variables with the data from the experiment and the equations that I told you before. And first, I'm going to write down what's given for the ball before the collision. So we have the original position, which was 59 inches, equal to 1.15 meters, and we have the gravity, and the velocity initially is 0 meters because I was holding the ball in my hand, and this is before the collision. Remember the principle of conservation of energy and impulse. We have that equation, and so we have those. And the reason I scratched this out because this is the kinetic energy. I scratched it out because when I'm holding the ball, it's not moving, and therefore it has to be 0. And the same with this is potential energy, which is U2, and I scratch it out and it equal to 0 because when it is moving, this is when the ball moving after I have released the ball. So when the ball is moving, potential energy cannot be any number except 0. So there. And so I just plug in the numbers that I got from the experiment, and I solve for V2, which is the velocity when the ball is moving. And there is the after the collision. The same equation, but now is when the ball moves from the ground up to basically when it rebounds from the ground up to the maximum height. And right now we can see that the potential energy is 0 because again at this stage the ball is moving from the ground up to the maximum height, and is 0. And in contrast to that is when right here, once it reaches the maximum height, it will stop temporarily, and therefore it equal to 0. We will use this equations, this one, for the next calculation. I mean for the next trial as well. And so I just solved them, and I got 1/2 v initial velocity squared equal to gravity times final height or final position. And I have what I knew was what I got from the experiment was the height, the final position, 20 inches, and that's equivalent to 0.508 meters. And so I just plug into the equation right there, the equation that I got. And since we don't have v, we have to find initial velocity, which is when the ball from the ground goes up to the maximum height. And there it is. That's the equation. That's the answer for the initial velocity. And eventually we need to find the coefficient of restitution to see how much kinetic energy has been lost or converted into other forms of energy such as heat or work done. And this is 0.582. And because the value of coefficient of restitution has to be either 0, 1, or between 0 and 1. And at 0, the ball does not move. If the value here equal to 0, the ball does not move at all when it hits the ground. If it's equal to 1, then it's going to be it's gonna go up, and the final height would equal to the initial position. But since it is between, we know that some kinetic energy has been converted into heat or other work form. So there is that is the first trial, and I used the height or the initial position of 59. And now look at the second trial here. Same method, the same same equation there. You see the same thing. I've just scratched things out. This is trial 1, and the same equation. I just scratching it out. I just copied this part down here because it happens in the same process. and so I just, in second trial, I just use 49 inches, and is equivalent to 1.2446. And so the same as the first trial, I calculated the same way. I just use the equation I plugged in, and I find V2. And the reason to do the second trial is to check to see the coefficient of restitution could be the same with the initial one. So after I've done all the work, I got the initial velocity when the ball rebounds is that, and I just plug into the equation of coefficient of restitution, and eventually I got this answer. Believe it or not, you can go ahead and use calculator and check it again, but that's the answer that I got from my calculator, which is exactly the same, pretty much the same with the trial one, the coefficient of restitution of trial 1 there. Trial 1 and trial 2, you see there is 0.582 and 0.582. And if you want to know more, this is trial 3. Still the same process. I just, instead of plugging in 49 inch or 59 inches, I just plug it in now 36 inches or 0.9144 meters right here into the same equation, and eventually for the value of coefficient of restitution, I still get the same answer, and that is my answer, which is exactly the same with the one that I got for first and second trial. And thank you so much for watching. If you have questions, please feel free to add comments below, and thank you.